Cool, so in this video we'll be looking at quadratic inequations or inequalities, and again very similar to linear inequations or inequalities, the symbols are exactly the same, or the signs are exactly the same. So you got less than or equal to, more than or equal to. So let's go over an example of what quadratic inequations look like. Okay, so say if we had a quadratic x squared plus x is less than 12. Cool. Now we rewrite this quadratic as we would like in our form ax squared plus bx plus c. So we take the 12 across and it becomes negative 12, so you get x squared plus x minus 12 is less than 0. Now treat this quadratic equation, if you forget about the less than 0 part, just factorize it as you normally would. Now I'll go through it quickly and I'll just say, well, if we factorize it, it would have become, cool, and we know that x minus 3 and x plus 4 are the roots. Okay, so we know the roots, I'll write it over here. The roots for our equation is x is equal to negative 4 and x is equal to 3. Okay, and I'll actually draw it up real quickly. Okay, just a rough drawing. So we've got, say, negative 4 around here, positive 3 over there. Cool, might look something along the lines of that. Not a perfect drawing, but you get the idea, I guess. Cool. Okay, and it's a positive quadratic since the a value is a positive number. There's no negative numbers. Cool, and we're trying to determine when this is less than 0. Okay, for what values of x is it less than 0? Well, if you look at the quadratic, and if we just highlight it, we're looking at these values down here. Okay, so for these values of x, the y value is actually, or the y-axis is below 0. So we can rewrite our equation and say, well, actually, it is below our roots. So if you think about it, well, if that's negative 4, okay, therefore it must be greater than negative 4. X must be greater than negative 4 because the numbers are increasing and it's below 0. Cool. Or x must be less than positive 3. Alright, and since it's continuous, you can rewrite this as it is between negative 4x and 3. And these are the values, or the range of values, where this equation is true for these range of values. Cool? So let's look at another example. Okay, another example, let's just say we had x squared minus 2x is greater than x plus 1. Cool, and again we rearrange this as a general quadratic equation if this was an equal sign. X squared minus 2x minus x minus 1. So we took everything across the inequality symbol and made it greater than 0. Okay, we can simplify it. Sorry. Cool. And now we want to find what the roots are. Cool. So for the roots, we may use the quadratic equation. I'll do it in a different color. Okay. So I'll skip through the steps real quickly. So it'll be 3 plus or minus 3 squared minus 4 bracket 1 times negative 1 over 2. So we get 2 roots, which is 3 plus square root of 13 over 2, or 3 minus square root of 13 over 2. Okay, which equals 3.3, or it equals negative 0.3. Okay, so I skipped through I used the quadratic equation. Okay, if you're not sure how to use the quadratic equation, please do look at that video as well. So again, well, let's plot it. Okay, so it's a positive quadratic. Okay, so it'll be like a smiley face. And we know the roots are negative 0.3 and positive 3.3. So the quadratic may look something along the lines of this. Cool. And we want to find for all values of x it is greater than 0. So if we look at our y-axis, we're looking at these values down here. Okay, so for these values it is greater than 0. Okay, and we can say as it is getting less than negative 0.3, okay, it is becoming positive, and as it's getting more than 3.3, it is becoming positive. So we can say, well, therefore, it has to be less than negative 0.3, or x has to be greater than 3.3 for this inequality to be true. So really important, it is good to have a rough drawing of your quadratic equations to get an idea of what you are trying to find.